Okay. So, as I said, and if you guys remember, we actually mentioned geometric sequences way back when we were talking about arithmetic sequences too. Okay? So a sequence, okay, is a fancy word for just saying a pattern, right? Okay, that a list of numbers is a sequence. Okay, a list of numbers is a sequence. A geometric sequence, though, is a specific list of numbers. Okay, and the way you come up with that list of numbers is you are multiplying from one term to the next. Okay, that what you multiply by is called the common ratio. Now, that word "common," right, doesn't mean like it's every day you see it around, like this is common. Common means like you have it in common. It's more like that kind of use, where you share something. Listen up. Okay, so in common, right? So in other words, like these numbers, they all have an r that you can multiply by to get to the next term. Okay, that's that common ratio. Okay. So again, geometric sequence contain a pattern where a fixed amount is multiplied from one term to the next. That's your common ratio r after that first term. Okay? So remember that first term we use the not a sub n. We use a sub 1 for the first term, right? That's a common way to write it. Or it's also a common way to write f of 1 as well, I believe. That's right, f of 1. Okay? So a sub 1 or f of 1, that can mean the first term there. Okay, other ways to write first term. A sub 1 or f of 1. Okay, this is like sequence notation. That's like function notation for the sequence. Okay, so here's an example of a geometric sequence, right? Okay. The domain here, all right, where does our domain start? Well, that's right. This is kind of a good question here, right? So our domain, these numbers are not our domain. These are the outputs. Let me label these up here for you. Okay, I'll zoom in some so you can see them better. Okay. 2 is the first term, so we call that a sub 1. Okay. 4 is the second term, so it's a sub 2, and then a sub 3, a sub 4, a sub 5. You get the idea. The domain here, then, is the number of the term, like the location of it, okay? So in other words, the domain, what number do we start with for the domain? 1, because it's our first term. And then what will be the next term? 2, and then 3, and then 4, and then so on and so forth. We count all the way up, right? Dot, dot, dot. Well, yeah, I guess you could go to infinity or to n maybe or something like that. You wouldn't want to just say infinity there, Brady, because infinity also would imply like that you're counting like fractions and stuff like that. But you'll notice it's just all counting numbers here. We're just using all the counting numbers. Okay. Now, what is the range? What are the y values? What are the outputs attached with these numbers here? So, like, what y value is attached or paired up with the 1 there? 2. The output of 2, right? And then what's their second term paired up with? 4, right? It's 4. And then it's, after the 4 is 8, and then 16, and then 32, and you guys get the idea. 64, dot, 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 right? And that one also keeps going too. Okay? So the domain, you don't see it here. The domain is the term number. The range are these output values, the actual part in the terms in the sequence. Okay? Now, domain is just like the term number is really all it is. Number of the term. Now, we're looking at the graph over here. Okay, there's a graph of it. Okay, you see these dots? Okay. Now, what's different about this graph than a lot of the graphs we've been seeing lately? What's that? Okay, it's exponential. So the pattern is a different kind of pattern, right? Most of the stuff we've been looking at has been quadratic relationships with the parabolas. Is this a parabola shape? It's not, right? Okay. It's got part of a parabola shape to it, but it doesn't go back up over here somewhere. Okay, it doesn't like make a U. It just has this like kind of curve to it. All right. What else is different about this graph besides like the shape? Yeah. So Sky. Okay, they're not connected. Remember, we had a word for that. When the dots were not connected on our graph, we called that a what kind of graph? It starts with a D. What's that? Discriminant? No. That's what we just did last unit, but it does start with a D. Discrete. Okay? So the graph of a geometric sequence is discrete. Okay? Because it's individual points. Do you remember what we call a graph that's connected? Starts with a C. Not complete, not constant, nope. Convex is part of it. Oh, did you say that? Continuous, yes. So there's discrete individual dots that make up your graph, right? And there's continuous connected dots. So it's like one full smooth curve kind of thing. Okay? All right. Sorry, that was just, again, a little review. All right, what's our common ratio in this particular case? 2, right? Because every term we multiply by 2 to get to the next term. So yeah, we're multiplying by 2 every time. Okay? If you're ever unsure, just take the next term and divide by the previous term. If you're ever unsure about how to find that common ratio, take your next term and divide by the previous term. So that's like 4 over 2, but it's also 8 over 4 or 16 over 8. Bless you. Okay? So yeah, if you can't figure it out, you can calculate it. Okay? So let's go ahead and look at these geometric sequences. So we're told they're geometric. That means they must have a common ratio. Okay? Since they're geometric, they must have a common ratio. So we're going to identify what the common ratio is for some of these patterns here. Bless you. Okay, you're welcome. All right, so Sky, how about letter A there? Sky, can you tell us what's the pattern here? What are we multiplying by every time here? 2, that's right. 5 times 2 gives us 10, times 2 gives us 20, times 2 gives us 40, so the common ratio is a positive 2 there. Okay. How about letter B? Let's go to Sierra. Sierra, what do you see here? What's the pattern? Negative 11 times what will give us 22? Times, we're multiplying. So yes, I see what you're thinking there, but what would I multiply negative 11 by to get a positive 22? What can I do? Negative 11 times negative 11, be careful. Let me show you here. That gives us 121. I think you're onto something there. Yes, only multiply. Negative 11 times what will give us a 22? Yes. But be careful, negative 11 times a 2 will give me negative 22. There you go. Very good. And then we'll multiply by another negative 2. That gives us the negative 44 times another negative 2 gives us the positive 88, so it's a negative 2. And again, folks, if you're ever unsure, okay, just take your next term, divide by your previous term. Next term, divide by previous term. Next, divide by previous. Okay? Shh. All right. Letter C. I'll take volunteers for this one. What is the common ratio here for letter C? Alex? 2/3 is correct. Okay, 2/3. Now, this one's funky because we go from a whole number to a fraction, and then we just have more and more fractions here. Okay? But you can kind of see it if we put that 4 over, what can I put this 4 over? What number? A 1. And look at it makes it a little bit easier to see, right? We go from 4 to 8 to 16 to 32 to 64. So we're multiplying by 4 every time in the numerator. Oh, sorry, not 4. We're multiplying by 2 every time in the numerator. And then to go from 1 to 3 to 9 to 27 to 81, what are we multiplying by every time in the denominator? 3. So it's a 4 every time, it's a 2 every time in the numerator, a 3 every time in the denominator, so it's 2/3, right? That doesn't make it that hard then. But again, if you're not sure, take that second term, 8/3 for example, divide by your previous term of 4, hit math, enter, enter, and there you get 2/3. Okay, so you can see you'll get the 2/3 if you just do that next divided by previous there. Okay? So, for geometric sequences, remember, we have this thing called the common ratio. It's what we're multiplying by every time. Okay? What's the name for the thing in an arithmetic sequence then? Yeah, it's D. What does the D stand for, though? So R stands for common ratio. For arithmetic sequences, the D stands for common... You remember? Difference. Okay? Because what are we doing in an arithmetic pattern? In an arithmetic sequence, we are what every time? What's the pattern? Adding every time, or subtracting, but it's adding a negative, you could say. And then for a geometric pattern, what are we doing every time? Multiplying. So for arithmetic, you have a common difference. For geometry, you have a common ratio. Okay, so A, B, C, D, E, F. Go ahead through there. identify whether they are arithmetic, geometric, or neither. If it's arithmetic, find the common difference, and if it's geometric, find the common ratio. Okay, so go ahead, A through F there, identify it as arithmetic, geometric, or neither. Okay, that might not be there still. I mean, there might still be a pattern, but it's got to be. If it's arithmetic, name it arithmetic. If it's geometric, name it geometric. Okay, so go ahead, try those out. Identify them right now. Okay, identify them right now. When Sierra comes back. Yes. Need help? What's the trouble?
That would make it so it's addition geometry.
So, yes. Because when you divide by the same number every time, that's the same thing as multiplying by the reciprocal of that number. So, for example, if you're divided by 5 every time here, that's the same thing as multiplying by 1/5. So, yes. Okay. Tell me if they're arithmetic, geometric, or neither. Okay, and then tell me if it's common with the common ratio or common differences. Yes, ma'am. Sure. Okay. So how can we go from 4 to 10? What can we do? Yes. Okay. How about from 10 to 18? Can I get there from adding 6? No. Okay. So is this pattern arithmetic? Nope. It's not. Okay. So it's not arithmetic. Can I multiply 4 by something to get 10? We can. It's not going to be a nice number here. So let me show you. Is it 2.5?
Yeah.
Okay. So to figure this out, you can take your calculator, okay, and take 10 and divide it by 4. So 2.5 times 4 will give you 10. 4 times 2.5. 10. Now let's see if I multiply 10 by 2.5. Let's see what I get. I get 25. I'm supposed to get 18. So is this pattern geometric? It's not. So it's not arithmetic. It's not geometric. Therefore, it is neither. Okay.
It's compounding as well. So you have to say to yourself,
Does that make sense? So then try letter Z. Okay. These are all geometric systems. A, B, C here. Okay. Because you're multiplying by the same amount each time. You're welcome. All right. Other questions on anything?
what you gonna see?
Identify as geometric or arithmetic. You're also supposed to tell me what. So if it's geometric, tell me what you're multiplying by every time. If it's arithmetic, tell me what you're adding by every time. Are you doing okay? Letter A? Yeah. Okay. Is it arithmetic? Are you adding by the same amount each time? No. Is it geometric? Are you multiplying by the same amount each time?
It's consistent.
It's kind of hard to see, but so like for example, if I take 10, the second term, and I divide by 4, 2.5. So in other words, 4 times 2.5 gives me 10, right? Now if I do 10 times 2.5 to get the third term, we get a 25. So it's definitely not arithmetic, right? We're not adding by the same amount each time. It's also definitely not geometric. We're not multiplying. It's neither.
So we know it's arithmetic.
Just say neither.
Arithmetic.
Arithmetic.
Geometric and aerometric.
Nice.
I hate that word. It's hard to do. I can't pronounce it very well. But English is not my forte. What'd you come up with? You're just throwing out any numbers, aren't you?
No, I know that one's not either.
Same amount.
That one's neither. All right.
You better figure multiplying the same amount.
What is the term? What is the? This one I want to
Divide to that one.
always do next term divided by the
Yes, you're adding
previous
this time.
term.
You have to have the
So
same
you've got a
amount.
calculator. What is 125 divided by 625? It's 0.4.
Dividing by 5.
Just going through it.
Actually, then
Is there
multiply
a
by
pattern between these two? What is 27 divided by 81?
Divided by 5 is multiplied by 10. So it's multiplied by the same
Because it
amount.
should show us a pattern. Yeah, what is 27
Correct.
divided by 81?
Neither.
Okay, now use that.
I'll show you what that is in a
3
second here.
times by 27. Do that answer times by 27. Bingo. So you just found out that is geometric because we didn't come in or something.
Yes, I'm going to have a lot of Algebra 2 students in though because they're taking a test tomorrow and they'll be my focus. But I can call you in if you want to.
Okay, so that's geometric. Now down here, look at this. How do I go from 8 to 1?
Can you tell me what your multiplier is?
Subtracted.
Yeah, you're
Does that
multiplying
match?
negative
1
2.
minus 7 is equal to negative
Because
6.
you take that negative 4 and multiply by
So
negative
that
2
is
is positive.
Oh,
But then times by 2 negative
remember, I
6.
get
Very
if
good,
it's a
Jonathan. Very
difference
good.
Gotcha.
Good eyes.
adding a negative number or adding a positive number. That's
Like 30 more seconds here. 30 more seconds. All right, finish up here. Remember, don't only identify whether it's arithmetic or geometric. You got to tell me if it's arithmetic, what's the common difference? If it's geometric, what's the common ratio?
This thing is hard. I'm gonna be honest with you. This stuff,
All right.
the next term, in my opinion, sorry. Some kids love some stuff. I hated it. Okay. I still don't even like teaching it. I think it is hard, in my opinion. Some kids do really well with it. Me personally, I think it's challenging. So they're saying,
Okay, time's up. Here we go. Let's see whose number is up. Hannah T, letter A. Arithmetic, geometric, or neither? Neither. Very good. Okay. We're not adding by the same amount each time here, right? It's plus 4, then plus 8, then plus 10. Oh, sorry, plus 6, plus 8, plus 10, plus 12. So we're not adding by the same amount each time. We could try multiplying here too. Again, to check what you're multiplying by, take your second term, divide by that first term, you get 2.5. So in other words, 4 times 2.5 gives us 10. But then 10 times 2.5 does not give me 18, it gives me 25. So it's not geometric either, so it's neither. Okay? All right, let's go to Olivia. Olivia, letter B. Arithmetic, geometric, or neither? Geometric. That's right. Good job. Did the inflection in my voice make you concerned? Okay. What are we multiplying by every time? Shh. Olivia, please. Sorry. This is a bit tricky to see. 0.2, yes, 1/5. 1/5, exactly right. If you hit math, enter, enter, it'll convert it to the fraction for you. So yeah, you can say 0.2 if you want to, or you can say 1/5 there. Very good, that's right. I thought you were going to say 0.25, and I was like, ooh, close, but you just said 0.2, and that is right. All right, let's go to Sierra. Sierra, letter C. Arithmetic, geometric, or neither? Geometric is right. Geometric, what are we multiplying by every time here, Sierra? Close. We're dividing by 3 every time, right? So dividing by 3 is the same thing as multiplying by the reciprocal, which is 1/3. Okay? So Sierra, if you see, and this is for everybody, if you see a division, right, if you're like, oh, we're dividing by the same amount each time, then instead multiply by the reciprocal of that number, and you've got your multiplication value. So the common ratio is 1/3. Okay? Thank you, Sierra. Let's go to Grayson. Grayson, letter D.
Letter D, I said geometric.
Geo? Okay, what are we multiplying by every time here? Grayson, what are we multiplying by every time here? That's okay.
So,
Times 2, right? And then times 2 would be
4. So, 2. So it's 4.
So is this geometric? So we are multiplying every time, but it has to be multiplying by the same amount each time too. So this is neither. Okay? This is neither. This is actually something called a factorial. It's like 1, and then 1 times 2, and then 1 times 2 times 3, and then 1 times 2 times 3 times 4, and then 1 times 2 times 3 times 4 times 5. Okay, it's factorials. If you see this in your calculator, it's this. This is a little bit later mathematics that we won't see in this class, but that's what those are.
It's calculus.
Not calculus. Probability. You'd see it in there, like stats maybe, if you guys take stats. Anywho, just a little something. Frank, letter E. Arithmetic, geometric, or neither?
Geometric.
Geometric. Very good. What kind of gave it away here? It was geometric, Frank. Anything?
It kept going up by 2.
Okay, but not just, well, so we're multiplying by -2. Very good, yeah. You see that alternating? This is alternating, right? Negative, positive, negative, positive, negative, positive, okay? That indicates multiplication, right? Multiplication with the negative number. Okay, when you see that alternate, now it doesn't always have to be that way, but in this case it definitely is. Okay, last one, letter F. Let's go to Anna W. Anna W, what do you say? Arithmetic, geometric, or neither? Arithmetic. Okay, and what then is the common difference? -7 would be your common difference there, okay? So remember, arithmetic patterns, you're adding the same amount each time. What are we adding every time? -7. Plus -7, plus -7, plus -7, plus -7. Okay? Questions on any of that? All right, no questions? Turn your paper over, please. Okay, it's blank. But we're going to use this space to write our formulas. I'm going to review arithmetic formulas, and I'm going to then introduce geometric formulas to you. So let's do the arithmetic review first here. Arithmetic sequence formulas. Okay. So, this formula you will not need to memorize. Okay, I think this is called the explicit formula, I want to say. So this one you don't have to memorize. Oops, I already messed up. Doggone it. Sorry, folks. Let me see if I can fix this without making it worse. Okay, I'll make that disappear. Okay, so a sub n equals a sub 1 plus n minus 1 times your common difference. Okay. You guys remember seeing this formula before? Okay. So it's the nth term, So if you want to find like the 100th term or something like that, you would put a sub 100, okay, equals a sub 1 plus n minus 1 times d. Okay, so a sub 1, that stands for your first term. Right, n stands for the number of the term, and d stands for common difference. Okay, and again, that's explicit form. Okay, and that's the nth term. Right? Is that ringing a bell? You guys remember seeing that before? We did it. We did it. Okay, believe it or not. It's been months. But we did do it. Okay? You do not need to memorize this formula, but you need to know how to use it. You don't need to memorize it, but you need to know how to use it. Okay, that was explicit form. Now, we had this other form that some folks had some difficulty with, and it was called the recursive form. And there's two different ways you could write this. Well, there's a couple different ways you could write it. Okay, so I could do it this way, for example. Okay, there's like several different ways to write the recursive form here. So I wrote all of them. But the big idea for recursive, it's like next equals previous plus d. Okay, next equals previous plus your common difference. Okay. Next equals previous plus your common difference. I'll explain that in a second here. Is everyone done looking at the explicit form? Can I move it over? Is anyone still writing the explicit form out?
I am.
Okay. Oh, no, you got the recursive stuff. Okay, I was just going to zoom in on this. Okay, so I want to zoom in on this because students, I remember in my class, and I think it was kind of like all the classes, had a little bit of difficulty here with this recursive form. So I just want to briefly touch on it one more time before we talk about the geometric stuff again, okay? So, recursive form is a different way to write the a formula or just kind of like show the relationship for a pattern, okay? Explicit allows us to find any term in a pattern as long as we know the first term and the common difference of the pattern, right? Explicit form allows us to find any term. We can find the 100th term, the 1,000,000th term, whatever, okay, as long as we know the first term of our pattern and the common difference. Recursive form, it's more limited, but it's also simpler to do. Okay, recursive form allows us to come up with a relationship, but you have, in order to find the next term, you need to know the previous term. Okay, in order to know the next term, you need to know the previous term and then add your common difference, right? Same thing here, right? This is the next term, n plus 1, and that's the previous term, just n. And again, add your common difference. Or in a different way to write it, you can use functions. F of n is the next term, f of n minus 1 is the previous term, and you add your common difference to get the next term, right? F of n is your previous term, add your common difference, you get the next term, f of n plus 1. Okay? So 4 different ways to say the same thing. Next is your previous plus your common difference. That's recursive. Okay? So if I wanted to find the 1,000,000th term using this, I would need to know which term. If I wanted to know the 1,000,000th term, I would need to know, well, not the 1,000,000th, let's just do the 100th. If I wanted to know the 100th term, I would need to know the 99th term, the previous one to it, right? And then I just add my common difference. If I wanted to find the 1,000th term, then I would need to know the 999th term. Okay, you see what I'm saying? In order to use recursive, you need to know the previous term. For explicit form, if I want to know the 1,000th term or the 100th term, okay, here I only need to know the first term and my common difference, and then I'm good to go. So that's the difference, all right? Or one of the differences there. All right, now let's talk about geometric. And again, I'll give you the explicit one first. You also will not need to memorize this, but you'll need to know how to use it. Okay, so here's the geometric one. Okay, a sub n equals a sub 1 times, now it makes sense here, right? We're multiplying because what's a geometric sequence? You multiply by your for your pattern. So we're going to multiply by r to the n minus 1 power. Okay. And so there it is. There's your nth term again. There's that first term, just like we had in the arithmetic. R, which stands for the common ratio. Okay. And then n, which stands for the number of the term. Okay?
Is that A1?
It's a sub 1. Sub 1. Mm-hmm.
One just seems like.
Sorry, yep, a sub 1. Okay, questions on this formula at all? Notice the r is in parentheses, and the n minus 1 is your exponent. Yes?
What was the n minus 1? What did that mean?
N, here, I'll zoom in on this one for you so you can see it better. There you go. N is the number of the term, and you subtract 1. And the reason why we have to subtract 1 is because we already have the first term right here. So we have to multiply by r n minus 1 more times to go out to the next term and stuff like that. Okay?
N plus H term.
The a sub n, the nth term there.
It says N plus H term. No, below.
Number of the term.
No, I mean like below A of N. To the left.
Nth term is what that's supposed to be. Nth term. Nth term. So again, explicit form. If you wanted to, you could find the 100th term without having to find all the previous terms before it, right? That's the beauty of this explicit form. All right, and of course then we have a recursive form as well for this. Okay, so again, recursive form. Okay, in this case, the big idea, and again, I'll zoom in on this one. Can I zoom in over here? Yeah. Okay, recursive form, the big idea here is that the next term is equal to the previous term times r. Okay? Next is equal to previous times r. That's all the big idea for recursive form is. So for example, if I have a sub n, then to find a sub n, I need to know a sub n minus 1, and I'll multiply it by r. Okay? Or, if I want to find a sub n plus 1, that's equal to a sub n times r. Okay? Next is equal to previous times your common ratio. Next is equal to the previous term times the common ratio. And again, I can do it with the function notation too. F of n equals f of n minus 1 times r, or f of n plus 1 equals f of n times r. Okay, these are all saying the same thing, basically. It's just where they're starting and where they're going to. Okay, but it's basically saying the same pattern. Okay.
So are explicit and recursive saying the same thing?
Are explicit and recursive the same thing?
Yeah.
They're describing two different things here. We'll get that back there, and then everyone else on that. Explicit and recursive are two different things, two different
So
forms.
when you say solve recursive,
Yes, it will be clear about whether we're talking about explicit or
so
recursive.
we don't have to remember this.
You'll need to know this format, yes. This will not be given to you. But it's the easier one to remember because it's basically just like, how do you take one term and then get to the next term? And for geometric, you're just going to multiply the previous term to get the next term. So, thank you. Okay? And then for arithmetic, you're just going to add to get the next term. That's it. Add your common difference, add your multiplier. Nth, like what does this mean? So nth just means it's like a placeholder kind of thing. It's like a blank. So it's like the n could be 100. N could be 100, which means you're trying to find the 100th term.
So what's the formula on that?
So a sub 100, right, is what you'd find, and then you put a 100 in for the n right there.
Is it always going to be 100?
Well, it's whatever term you want. You tell me what you want. If I want the 50th term, I'll put 50 in for the n, 50 in for the n, and go from there. Make sense? Okay. Hold this nearby because we're about to do some problems, okay, with that formula, with those formulas. Okay? So I'm going to skip these first, I'm going to skip these first 6 here. I think you guys are pretty good identifying that. But let's look at the numbers 7, 8, 9, 10, 11, and 12 here. Okay? These say to find the common ratio. Okay, find the common ratio here. Okay? So let's go to somebody here. Cameron. Cameron, let's take a look at number 7. Okay, Cameron, what's the common ratio here for number 7? So, 2, yeah? 3 times 2 gives us 6. 6 times 2 gives us 12. 12 times 2 gives us 24. That's right. So R is 2. Okay? Now, again, if you are ever stuck, if you're like, I can't tell if this is geometric or not, take your second term divided by your first term. All right? So that's equal to 6 over 3, right? Or you could say that's equal to 12 divided by 6. Or it's equal to 24 divided by 12. Just take a next term divided by a previous term, and that will give you your common ratio. Okay? All right. Let's see here. Goodness, I want to... Yeah, okay. Let's flip over here to the back. These are the problems I really want to work on because I think we're going to be okay. Okay, we'll practice a few of these. Okay? So, 17 says to find the 8th term. Okay? Do I need to use... Come on, man. Do I need to use my explicit form of my geometric sequence? Do I need to use this formula to get the 8th term for this problem? Do I need to use this formula? Don't need to. What could I do? Yeah, just keep doing the pattern, right? We already have the first 4 terms, so just extend the pattern out until you find the 8th term. So you could do that, But let's go ahead and just use the pattern. Let's use the formula here, okay? So we want to find the 8th term, which means I want to find a sub what number? 8, right? Okay. What's my a sub 1 according to my sequence here? 1. Right, there's a sub 1 right there. Okay. Times, what's our common ratio here? What are we multiplying by every time? 1 times what gives us negative 4? Negative 4, yeah. And then let's just check it though. Times another negative 4 gives me a positive 16. Times another negative 4 gives me negative 64. So yeah, our common ratio there. Okay, we're multiplying by negative 4 every time. Okay. And then what's my n? 8, right? It's the number of the term, 8. So it's 8 minus 1. And so we'll just go into our calculators here. Okay, we'll just type in 1 times negative 4 to the 8 minus 1. Now be careful here. Okay, if you're going to type in 8 minus 1 like I am, if you have a calculator like mine, then you'll get the right answer. Okay, but if you have a calculator, some of you have a different calculator, and it looks like this when you type it in. Okay, if your calculator looks like that when you type into the 8 minus 1 power, you're going to get the wrong answer. Okay, that's incorrect. What should I have done here with this? Parentheses. Okay, if I put parentheses around it, then it's okay. Okay, that is the correct answer. So please be careful here, folks. Or just do the subtraction. Just make it to the 7th, like John was saying. Okay, you can also just do the subtraction in your head and put 7 in.
Did you do the 8 because it's all numbers kind of contributed?
We want the 8th term. So then, again, looking at the formula here, right? This n and this n are the same number. They're both n, so 8 is what goes in there. Okay, and so we get negative 16,384. Okay, 8th term. What do the directions say? Okay, yes. It's messed up? Okay. Come take a look at it here real quick. Actually, Ms. Jeeber, you want to take a look at it? Alyssa's right there. Sorry, her calculator says, she says it's messed up. So, all right. Thank you, Mr. Sieber. Appreciate it. All right, let's try another one. All right, let's do number 19. Okay, let's do that one. Now this one we're asked to find the, what is this? What does a sub 12 mean? What term is that? The what term? 12th term. Again, we have the 4 terms here. We could just extend the pattern out if you wanted to, but let's use the formula. Okay, so again, for the formula here, I'm going to do a sub 12 equals, all right, what's our first term? Let's go to Alessandro. Alessandro, for this number 19, what's our first term? 1 times. Alessandro, can you also identify what's our common ratio here? What are we multiplying by every time? Negative 3. Very good, sir. Yes. To the 12 minus 1 then power. Okay. Again, it's 12 minus 1, n minus 1. N was 12, so 12 minus 1 there. Okay, type in your calculator. Oops, I'm going to zoom out some a little bit there now. Okay, so again, make sure you're careful. 1, use parentheses for the base. Use parentheses for the power there if you don't actually just do the subtraction in your head. And then there's your answer. Okay. Negative 177,147. These numbers get out of control pretty quick. Right? They get out of control, they get really big really quick because we're multiplying, repeatedly multiplying, right? So it gets a little crazy. We'll do 2 more here. I'm going to do 1 explicit and 1 recursive. And then if people need more help, we can do that too. Okay. For the explicit formula, we have 21, 22, 23, 24. Which one do you want to do? 24 is what I heard. All right, we'll do 24 here. Let's zoom in on that bad boy. Okay. Explicit formula. Where did I put that? Put it down, and now I don't know where it is. Word? Oh, I know where it is. It's hidden. It's hidden. All right, so remember the explicit formula? That's this formula right here. Okay? So we're not asking for a term. We're just coming up with a formula here. So we'll say a sub n equals, okay, what's our first term for 24? 1 times, what's the common ratio here? 6. And then again, we don't know the term we're trying to find, so we're just going to leave a generic n in there, minus 1. And there's our formula. That's it. Okay? I can then use that formula to come up with whatever term I want. If I want to find the 100th term, I'll put 100 in for the n there. Okay. Questions on any of that? Easy peasy, right? Just plug it in. All right, let's do the recursive formulas here. All right. What do you want to do? 25, 26, 27, or 28? Pick one.
25.
Oh, I heard 26 first. We heard a quick draw on the 26 there. All right, quick draw on the 26. Okay, so again, this is a sub 1, a sub 2, a sub 3, a sub 4, like that. Okay, we keep going. Okay, so here's how we're going to do this. Okay, let's look at these recursive formulas. Okay, to find my next term, I need to take my previous term and multiply by the common ratio. All right, so that's easy. To find my next term, I'm going to take my previous term and multiply by the common ratio. What's the common ratio here? 2. That's it. We're done. Okay, we can write it a different way. Right, so that's if I have a sub n be my next term. But what if I want a sub n plus 1 to be my next term? Then what would be the previous term? If a sub n plus 1 is my next, what's the previous term? A sub n. And we'll multiply that one by 2. Okay, or we could do it in function notation. F of n is equal to f of, again, if that's my next term, what's previous to n? N minus 1. Again, times your common ratio of 2. Or f of n plus 1, if that's my next term, what's previous to n plus 1? Just n, right? And we'll multiply that one by 2. Okay? Mr. Wade, do I have to write all 4 of these when I answer these questions? No. No. Do one. Okay? But you should be able to understand all 4 if you see them in the wild or on your own. Okay? You should be able to see all 4 if you do them in the wild. Yes. Yes. Okay? So, your homework, I want you to do the odds, front and back. Odds, front and back. Mr. Wade, we already did some of the odds. Good for you. All right, but I want you to do the odds, front and back, please, for your homework. You have 15 minutes. If you don't finish it, it'll be homework, okay? So let's get it done. Get her done. All right? Odds, please, for the homework.
Why would you do like 3 problems? You always do like 3 problems.
Well, I do 3 problems when they're like quadratic formula and they take, an hour for each problem. But when it's these, they're like short and quick, Okay, so again. Geometric sequences, worksheet. One through 27. Odds. Okay, so let's get to work on that. All right. Does anyone need a calculator to borrow? We're all good? Okay. You having trouble, Brady?